Welcome to Brain Vision.
Okay, the reduction of cyclohexanecarbaldehyde should look like this. Via the Wolff-Kishner mechanism, or the Wolff-Kishner reduction, would proceed as follows. First, you have your hydrazine, and it will attack the carbonyl carbon. Give us the following intermediate. Still have our oxygen. Now our hydrazine is attached. It has a positive charge because that nitrogen's got 4 bonds. And we still have this hydrogen that was on the carbonyl carbon to begin with. And actually, I'm going to redraw this, put an H there, and another H here, because this proton is actually going to do a proton transfer. So this oxygen is going to steal this proton. Oops, didn't draw that very well. This oxygen is going to steal this proton from the nitrogen. So the proton is transferring from the nitrogen to the oxygen, giving us like an alcohol. Now this nitrogen still has 1 hydrogen, but it should be neutral. It's still bound to the other NH2, and we still have our hydrogen here. Okay, now we're going to have this lone pair on nitrogen is going to push down while this OH takes off. This is one of the few times you ever see OH as a leaving group. Okay, now we've basically got somewhat of like an imine. And it still has a proton on it and a positive charge because nitrogen has 4 bonds. And we've still got this OH minus floating around, which can finally deprotonate the nitrogen and give us our first sort of major intermediate. If you were to just react a aldehyde with hydrazine, this is what you would get out. But then we follow this up to finish the basically the deprotonation and elimination of N2. Right. So this is typically done with some kind of diol that's typically given, so oftentimes this will be stylized as like the overall reaction would be NH2 in 1,3 or 1,2 diol, ethane diol, and some sort of base. The base will essentially turn this 1,2 ethane diol into O minus. Okay, so that's where I'm going to introduce that, and that's why. That's where that's coming from. It's just one of the reagents. Just clear some space here. Okay. And I'm also going to redraw this just so it's easier to show the next deprotonation step. So a molecule of that will come in and deprotonate. Oops. Great. Now the next step is just a little bit of a rearrangement to create an anion on the what used to be the carbonyl carbon. All right. Now we've got this. Oops. Alcohol still floating around that's been protonated since we last saw it. And the lone pair on this carbonyl carbon. We'll come and grab it. Okay, and at this point we're almost done. We really just need to basically lose our N2. So let me redraw this. Actually, this is once again O minus. And finally, that proton will transfer one last time to what used to be the carbonyl carbon. Finishing off the reduction.